Hello everybody. In this lesson we will study about irrational numbers. But before we get into the concepts, let's revise some of our fundamentals. What we know that all real numbers are classified as rational and irrational numbers. And we know that rational numbers are those numbers that can be expressed in the form P over Q, where P and Q are integers and Q not equal to 0. Any number that can be written in the form P over Q, where P and Q are integers and obviously the denominator Q should not be 0, is called a rational number. For example, 2 over 3, 5 over 8, and so on. And irrational numbers are those numbers that cannot be written in the form P over Q. These are called irrational numbers. We have studied about them in our lower grades. For example, of irrational numbers, square root 2, square root 3, root 5, root 7, pi, and so on. So these are irrational numbers. Now, in this lesson, we will be focusing on how to prove that these numbers are irrational. What is the method of proving that such numbers are irrational? Let us see how we go about proving this. Before we get into the method of proving irrational numbers, let us first try to understand a concept. Take, for example, 4 squared. What is 4 squared? It is 16. Is 16 divisible by 2? Yes, it is 8. Now observe. Is 4 also divisible by 2? Yes, which is 2. Okay, let's try another. What about 6 squared? It is 36. Is 36 divisible by 3? Yes, it is 12. Observe now. Is 6 also divisible by 3? Yes, it is 2. So from this, can I say that any number a squared, if it is divisible by a prime number p, it implies that a is also divisible by that same prime number p. So we can formally state this as a theorem. Let p be a prime number. If p divides a squared, then p divides a, where a is a positive integer. So this in itself is a theorem which we will be using to prove irrational numbers. Prove root 2 is irrational. Now, in order to prove that root 2 is irrational, let's assume for the time being the contrary, that root 2 is rational. Now, if root 2 is rational, that means root 2 can be written as a fraction of any two numbers r over s, where r and s have a common factor. It can be divided by some common factor. And when we divide r and s by that common factor, we land up with some other fraction a over b, where a over b are co-primes, meaning now the common factor which divides A and B is 1. So we can write root 2 then will be equal to A over B. We cross multiply. So B square root 2 is equal to A. We square both sides and we get B squared times root 2 squared is 2 equal to A squared. This can be further written as B squared is equal to A squared over 2. That means A squared is divisible by 2, which implies that A is divisible by 2. So then let's take A over 2 to be equal to some integer C. Then we will have A will be equal to 2C. Now we know that 2B squared is equal to A squared. Let us substitute A is equal to 2C for A in this equation. So we get 2B squared is equal to 2C the whole squared, which is going to be 2B squared will be equal to 4C squared. Therefore, B squared is going to be 4C squared over 2, which is equal to 2C squared. In other words, C squared is equal to B squared over 2. That means B squared is divisible by 2, which implies B is also divisible by 2. But remember, we said when we assumed root 2 as rational that A over B were co-primes, meaning they should have a common factor of 1. But we see over here that A and B have a common factor of 2 other than 1. Therefore, A over B are not co-primes, which are contradictory to our assumption. Therefore, root 2 is an irrational number. Let's try this. Prove root 3 is irrational. On the contrary, let us assume that root 3 is rational. So we are assuming that root 3 is rational. Now if root 3 is rational, then we can consider that root 3 will be equal to the fraction of some integers A over B, where A and B assume that they are co-primes. Co-primes meaning the common factor of A and B is 1. Now let's proceed with the algebra from here. We cross multiply, so B square root 3 will be equal to A. Square both sides, we get square root 3 squared is 3, B squared is B squared equals to A squared, and B squared equal to A squared over 3, which implies that A is also divisible by 3. Now let us take A over 3 to be equal to some integer C. Then by cross multiplying, we will have A is equal to 3C. Let us plug the value of A equal to 3C in this equation. We will have 3B squared equal to 3 times 3 times C the whole squared, because A is equal to 3C. So we get 3B squared equals to 9C squared. B squared equal to Or we can write it as c squared equal to 3b squared over 9, which is equal to b squared over 3. That means b squared is divisible by 3, implies that b is also divisible by 3. Now observe over here, a is also divisible by 3, b is also divisible by 3. That means a and b have a common factor 3 other than 1. But we assumed that a over b were co-primes, which is contradictory to our assumption. Therefore, root 3 is irrational. Hence, we have proved it by this method. Let's try this problem. Show that 5 minus root 3 is irrational. Now, in our lower grades, we have studied that the sum or difference of a rational number and an irrational number is always irrational. We have studied that. The sum or difference of a rational number and an irrational number is always irrational. Now in this question, we have to prove that 5 minus root 3 is irrational. Let us assume that 5 minus root 3 is rational. Hence, it can be written as a fraction of some integers a over b, where a and b are co-primes. Now let's rearrange this equation. Let's move negative root 3 on this side and a over b on this side of the equation. Then we will have 5 minus a over b is equal to root 3. Now 5 is an integer, a over b also is an integer because a is an integer and b is an integer. So an integer minus an integer, a rational minus a rational number, this will be equal to a rational number, which implies that root 3 must also be a rational number. But we know that root 3 is irrational. Hence, it contradicts our assumption that 5 minus root 3 is rational. Therefore, 5 minus root 3 should be an irrational number. Let's try this. Show that 3 root 2 is irrational. Now, in our lower grades, we have studied that a product of a rational number multiplied by an irrational number will always be an irrational number. Now, in this question, we will prove this. The product of a rational and an irrational number is irrational. Let us assume that 3 root 2 is rational. We are assuming it. So since we are assuming it is rational, it can all be written in the form 3 root 2 is equal to the fraction of some integers a over b, where a over b are co-primes. Then by cross multiplying, we have root 2 will be equal to a over 3b. Now, a is an integer, 3 is an integer, b is an integer. Therefore, a over 3b is going to be rational, which implies that root 2 must also be rational. But it contradicts our fact that root 2 is irrational. We know that root 2 is irrational, not rational. Therefore, 3 root 2 is an irrational number. Let's try this. Show that 3 plus 2 root 5 is irrational. Let us assume that 3 plus 2 root 5 is a rational number. Then it can be written as a fraction of two integers a over b, where a over b are co-primes. Then let's move the 3 on this side of the equation, we will have 2 root 5 is equal to a over b minus 3. Now if we take the LCM of this, 2 root 5 is going to be equal to a minus 3b over b. And then with further simplification, cross multiplication, root 5 is going to be equal to a minus 3b over 2b. Now look at this. A is an integer, 3 is an integer, b is an integer, and 2b will also be some integer. That means this whole part is going to be a rational number, which implies that root 5 is rational. But we know that root 5 is not rational. It is irrational. So it contradicts our assumption that 3 plus 2 root 5 is rational. Therefore, 3 plus 2 root 5 is irrational. Hence, we have proved the question. Let's try this. Prove that 1 over root 2 is irrational. First, before we even proceed with that, let's rationalize the denominator, which we have learned in our lower grades. Rationalizing of the denominator. We multiply and divide by root 2, which will be equal to 1 times root 2 is root 2 over root 2 times root 2 is 2. So 1 over root 2 can be written as root 2 over 2. Let us assume that root 2 over 2 is a rational number. Hence, it can be written as a fraction of two integers a over b. And now when we cross multiply, we have root 2 is equal to 2a over b. Now 2 is an integer, a is an integer, and b is an integer. Hence this will be a rational number, which will imply that root 2 will also be a rational number. But we know that root 2 is not rational. It is irrational. Hence, it contradicts our assumption that root 2 over 2 is rational. Therefore, root 2 over 2 is irrational, which implies that 1 over root 2 is also irrational. Hence, we have proved the question.